what is the Foucault's pendulum and why are flat earthers afraid of it? Supposedly, because everybody's been told that the Foucault's pendulum proves without a doubt that the earth spins underneath them. And that's how the Foucault's pendulum, that's why it moves around in a little circle like this, okay, underneath of the pendulum itself. That's the only way that people can understand it, because that's all they've been told. Now, ever since I started, with this flat earth movement, when I tripped upon it, actually, that came up, of course, very early, Foucault's pendulum. And it took a whole, 30 seconds to think about. The assumption is it's rotation of the earth. And I keep telling people, when I actually even respond to it, rotation causes it. Any kind of rotation. What about the ether rotating around the earth? Isn't that what we talk about? That's a possibility, at least. It's another possibility. Do people know that there's more than one possibility that can cause certain things, especially when you're talking about motion? When you're out at sea and you see a boat travel around you in a circle, it's hard to tell if you're the one that's moving or the other boat. You have to do some external experiments to figure out which. Same thing with the Foucault's pendulum. Now, supposedly Foucault's pendulum also is related to the Coriolis effect, which we've already debunked. A lot of anger with it with the other people, but we've debunked it. We've showed that it was an electromagnetic thing more than likely, correct? And why does the equator matter if it's pushing left at the equator? Why wouldn't it push left north of the equator too? Well, it does. So what's the difference? There is no difference. The difference is if you have a magnetic force traveling along that area there between the two tropic lines and the equator, and those are magnetic, then everything north of it will tend to repel away one way and south of it will repel another way. And again, I'm going to do another video with better description of the magnetic so you can really see how it works. It's going to freak you out. It shows perfectly why and how high and low pressure systems set up near the tropics. Anyway, so Foucault's pendulum. Let me ask you something. I've had, rough guess, 75 to 100 comments about Foucault's pendulum. 75 to 100. Nobody's mentioned one little fact that goes along with that. This shows how much trouble people take to research something. They're just like, oh, got him. Foucault's pendulum. I know that. I've been told that cause is caused by the rotation of the earth. Well, okay, let's take a look at something here. Have you ever heard of something called the effect? It's in obscure places. I mean, it's so obscure I can't even find out how to pronounce the name, although I'm sure it's there somewhere. The Huffington Post. I have to give the Huffington Post congrats on this one. I've hammered the Huffington Post on certain things before, not because of accuracy or whatever, but it's political bias more than anything else. But there's somebody here, Michael R. Powers. He's the author of Acts of God and Man. And then ramifications on risk and insurance. They don't sound like they're logically connected. In any case, the paradox of Elias effect. I want to read you the last paragraph, and I'm going to have a link to all this I show you below. All right? And except for maybe that video behind me where it's showing the pendulum going around. That's where they indoctrinate you at the mall and show you, oh, see how this is working? It's working because the earth is spinning underneath of it. That's why. Oh, yeah, that's why. Let's be brain dead. Let's go get our cornflakes and go home. I'm going to read you the last paragraph of this. It's entitled The Paradox of Elias Effect. Indeed, having been tricked by Elias paradox myself, now I have to explain what it is. Guess what happens during a solar eclipse? And what I found is, I don't have good documentation on it yet, but also during a lunar eclipse. I can't say too much about that yet because I'm early in my research on the lunar part of it. But during solar eclipses, you will find the Elias effect. And everybody's going to run to Wikipedia. And if you didn't see my last video where I talked about the nonsense of Wikipedia, they've got something wrong about this too. Some scientists in the 1900s discovered this effect. Wrong. It was discovered in the 1800s. Oh, but you should see the explanation they have on Wikipedia for this. I'll get to that. Talk about laughing at ridiculousness. Guys, if you don't, when I tell you what the explanation for the Elias effect is, and you don't see through that it's hogwash, I'm sorry, there's no help for you. Just go back to watching SpongeBob and anything else that has pictures of globes in it and stuff like that. All right? Just do it. So the Elias effect, they've noticed that supposedly at the North Pole, although I'll bet you there's never been a pendulum taken to the North Pole, the pendulum will turn 360 degrees in one day. At the equator, it doesn't turn at all. Wonder why? The Earth is still spinning, but it doesn't turn at all. But anyway, the closer you get to the equator, the less it spins. Let's say in North America somewhere, it spins 270 degrees in one day. It doesn't spin the whole 360. Once you get below the equator, south equator, it spins again and then gets, I guess, if you ever got to the South Pole, which nobody ever does, it would be 360 degrees again in theory. So they say it's the Coriolis effect and the spinning of the Earth, right? Couldn't be caused by anything else. Couldn't be caused by the rotation of the stars around us and maybe the magnetic fields of those and or the planets and sun and moon going around also. Nah, couldn't be that. That would require some thinking. It's easy just to say, oh, company, he said that we go around the sun, so we have to believe that. So now you know what the Elias effect is, sort of. During a solar eclipse, guess what? If it's supposed to move, let's say, 10 degrees in so much time, 10 degrees in 30 minutes. Instead, it moves 5 degrees in 30 minutes, or 20 degrees in 30 minutes, or 25 degrees. There haven't been enough solar eclipses to get a good handle on it, and it seems to be variable all over the place. You get a solar eclipse, there's even been reports of the pendulum reversing during a solar eclipse. Or it goes much faster, or it goes much slower. Now, when we looked at the Coriolis effect around the tropic lines, and we showed that it was likely either the sun is positive and the moon negative, or vice versa, and those were magnetic, electromagnetic. It's an electromagnetic universe, guys. It's not a gravitational universe. It's not a gravitational universe. It's an electromagnetic universe. And the sooner we all get that down, the more we're going to understand how everything works. So I showed how the path of the sun and moon, sun in particular, causes high pressure systems to form. Works beautifully, doesn't it? Absolutely. And it shows why it doesn't happen near the equator. This would show the same thing. Because guess what happens during a solar eclipse? I already told you, didn't I? The pendulum does all kind of crazy things, and that's called the Elias effect. Wow. Not a one person, not one, mentioned Elias effect. This tells me that 100% of the people, this is called 100, 100% of 100 people just went to the gotcha mode, got lazy, probably went to Wikipedia, so they understood what a Foucault's pendulum was themselves, because they probably never heard of it until they were like, how do I disprove a flat earth? Foucault's pendulum. It proves the earth spins. How do you know that? It just does. Here's the last paragraph. Indeed, having been tricked by Elias paradox myself, I wonder why scholars don't spend more effort educating people how to make decisions correctly when confronted by uncertainties, rather than trying to describe, often with very elaborate, and I will add immature, mathematical models. Now, he just got done explaining that in chess, mathematicians, they have a paradox with chess. You have a 50% chance of winning, or a 50% chance of losing, or a 50% chance of a draw. How do you do that? 3 different variables, you have a 50% chance. It works. It's what it is. If you have equally matched people, set 2 computers up that were equally matched in chess, there's a 50% chance one will win, 50% chance one will lose, and 50% chance there's going to be a draw. So mathematical models don't always explain it, and the immaturity of people that don't understand these things, they just come on here and get angry. And they throw something like Foucault's pendulum, you idiot, and they haven't even looked at anything. Please look at stuff up, guys. All right, I know this is the postmodern era of kick back and take it easy. But you better get out of that mode anyway, because things are changing. All right. Let me pick it up now. How people actually make decisions incorrectly finishes that last sentence. Along these lines, one could ponder what the world would be like today if its successors of Copernicus and Galileo had spent their time studying the consequences of believing in a geocentric universe rather than trying to educate others that the earth revolves around the sun. Remember, this all came from those two idiots and the Church of England. Wait till I get into that. Likewise, one can ponder what the world will not be like in the future if we continue to ignore a last effect. Bravo. Bravo to you, Mr. Let me get his name right because he deserves to have his name mentioned. Michael R. Powers. He described perfectly how people, if they're confronted with something new, they just fall apart. That's what he's really saying there when he's talking about they don't know how to handle it. And of course, science doesn't want to touch it. All right, Wikipedia. Are you ready for science's explanation? Or maybe it's just Wikipedia's explanation. Science's explanation for why the Elias effect works. Why it changes pendulums all of a sudden when the sun and the moon come together. Now see, to me, that's a positive and a negative coming together in one place. That's what's messing up the magnetics. Temperature and pressure changes during a solar eclipse cause the pendulum to mess up. That's the theory. No lie. No lie. Because the moon moving in front of the sun, all of a sudden the sun isn't giving off its rays like it was. So now it's cooler. And by the way, when it's cooler, there is a very, very, very slight pressure change. On a barometer, it's 1/100th of an inch, if that. So temperature and pressure changes do it when the sun and the moon, when the moon covers the sun because it cools. So if you have a pendulum and all of a sudden you have a dark thunderstorm cloud move over the sun, does the pendulum mess up? No. No, it doesn't happen. We don't even have high tides during an eclipse necessarily, not unless it's due for it. So the magnetics or the gravitational pull isn't it. So do you believe that temperature changes from the sun causes the pendulum? Come on. I keep going to Aries failure, A-I-R-Y''S, Aries failure. Look up a YouTube video on it by Malcolm Bowden. Extremely good. That's the proof the earth doesn't move. So I knew the pendulum was wrong, so I had to sit and think about it for 5 minutes. Of course, I came up with other things like the ether could be spinning around. Any kind of motion could be doing it, or electromagnetic. Now, I didn't attach it to the sun and moon, but I did think electromagnetic because that's what I believe the universe is. Anyway, it explains so much more than gravity, guys. Thank you for helping spread the word because the pendulum actually proves that it's not caused by the Earth's spin. And the pendulum proves because it changes with magnetics now. Now we know the magnetics of the sun and the moon getting together. And we've already proven, haven't we, that the moon does not reflect sunlight to the earth. Boy, that got them all pissed off. It's all coming together, isn't it? It's falling apart for them, guys. It really is.